In our next section of gateway redundancy, we're going to talk about VRRP, Virtual Router Redundancy Protocol, and how it works in conjunction with HSRP. There's really no difference, other than the fact one is Cisco proprietary and VRRP is not. Other than that, just the way that they communicate back and forth is via IP instead of UDP, and VRRP uses IP protocol 112 to multicast address 224.0.0.18. Now, one quick note about 224, the 224 address space, that is going to be link local. In other words, you won't be able to route the multicast addresses or the multicast packets from one interface on a router on the same router to another interface on the same router. Once it leaves a router on a router's interface and is pointed to another router, as soon as that router receives it, that is it. It's considered one hop. There's a TTL value of 1 on it. So where HSRP was standby and active, VRRP is master and backup. And master forwards the virtual MAC address, backup checks to see if the master is up. They have preemption is enabled by default, and they use the priority of 100 by default. So we will go in and modify the preemption and the priority to suit our needs. It uses a virtual MAC address just like HSRP. This is it. The XX stands for the group number. And then you use the VRRP interface level commands. So that is pretty much the extent of VRRP. It's almost identical. So it says, after some debate, the design team has decided that they would prefer to use open standard based protocols whenever possible. So they have requested you modify your design to use open standards based VRRP as opposed to HSRP. Implement this change while maintaining the original design specification requirements. So what we're going to do is we're going to scroll up here, and we're going to keep all of this information right here, but we're just going to change over the commands to VRRP. So we're going to jump over to router 1, and we're going to do him first. And what I'm going to do actually is I'm going to do an end here. I'm going to do show run. No, I don't want to do that. I'm going to do, actually I'm right here, might as well. I'm going to take all this information right here, and I'm actually going to take this and I'm just going to change the keywords around. So I'm going to take this, I'm going to copy it into Notepad right here. And one thing, I don't know if you knew this about Notepad, but if you do, well, I can't really do it here, but if you do a Control F and look for standby and do find all in current document, it's going to find them. Here it is. We're going to do Control F, and you can actually replace all with VRRP and replace all. So now it's all that. So I won't save that. I just wanted to show you guys that command so that if in case you're in need of doing something crazy. So how did I do that again? It's a Control F. I do what I wanted to find. So I did Control find for standby, and then I found all in current document. Once it finds it all and it gives you that little pop-up window I had right here, I do another Control F, and then it'll pop up this window again. But what I end up doing, once you do find all, it's not going to find anything. So I do VRRP, I find all in current document. It found 29 hits. So what I'm going to do now is I'm going to hit Control F again, but you go to replace. So instead of replace 30, you're going to replace VRRP with VRRP, and you're just going to click on replace all. You can put whatever you want in here, replace all, and they were replaced, and there we go. So that's how I did that. So now I can go in here and just copy the config over. I can just type in no standby 1, and I can do, I'm going to do this. I'm actually going to copy this twice and come down here one more time, do this, and I'm actually going to get rid of this line of config and this line of config, and just delete this line. This will be router 4's config. So I'm going to pull up router 1, slide this guy down just so we have it, and what I'm going to do is I'm going to go to config T, interface fast season at 0/0, and I'm going to type in no standby 1. So then what I'm going to do now is it turns this off. I'm going to do this, copy it, and then replace it here. Oh, you know what? The timers are a little bit different. The timers, yes, I know. So what I'm going to do here, where it says the timers are a little bit different. You would type in timers are going to be, you're going to advertise, and then what you're going to advertise. So we're going to advertise millisecond is going to be 333, and then you don't advertise anything else. What VRRP does by default is it'll take the timers that you put in here. So the 333 that I typed in, it will take the 333. I thought I saved that, but I guess not. It'll take 1 second. It'll take the timers, so 333 milliseconds, times that by 3, and then it does a skew for the actual timeout, and I believe they divide it by 256 milliseconds, or something to that effect. I have to look this up actually, and then whatever this equals, divide that by 256, then you come up with whatever. So we do 3 sets of 333. So we do, alright, so basically the way that it works with VRRP's timers, we have the hello interval by default is 1 second, and then that automatically calculates the dead timer to be 3 times the hello. So it's going to be the dead timer, in this case default timers is going to be 3 seconds is going to be the dead timer. Now the skew, which is going to be some partial calculation, what it does is it takes the 256 in milliseconds, subtracts whatever the priority is. So in this case it's going to be 100 by default, which is going to give us 156, and that this number right here is then divided by 256, and that number gives you your skew. So if I was to pull the calculator in over here and do a clear, we were to take 256 minus 100 equals 156. Divide that by 256.609. So it's going to be 3.61 seconds. 3.61 seconds. Milliseconds. Or 3 seconds. 3.6 seconds for it to fail over. The skew timer is going to be, in case the third one is missed, it's giving it a half a second roughly by default. Assuming you're using default priorities, this is going to be it by default. This number will change depending on your skew numbers. So if you're using a 0.333 times 3 equals 0.99, and then you take 0.99, you clear that out, you take 256 minus, let's say the priority is 150, subtract that, that's 106, divide that by 256, you get 414, and then you add 4.414 plus 0.999, you get 1.4 seconds is going to how long it's going to take VRRP to fail over. Just thought you might want to know that. I don't think that's going to be on the exam, but in case it is, now you know how to configure it, or how to compute it. So we still have a default this guy. So what I'm going to do is I'm going to jump over to I have to go to router 4 and change the config over there. So what I'm going to do is I'm going to jump over to interface fastseason at 0/0 and type in no standby 1, and that'll take care of all of that stuff right there. So what I'm going to do is I'm going to jump back over to the notepad document here. I'm going to grab this guy. I'm going to say timers learn, and that's going to be something we're going to be able to do, and then the priorities are obviously going to be 100, and then we're going to decrement 60. So we're going to do copy this, minimize this, go to here, excuse me, and copy. And now this guy is the backup, And then what we're going to do now is we're going to do show VRRP. And so what we have, this is R4. We're going to drop out of here and do a show VRRP. We have the priority is 100. Preemption is enabled. Delay is 30 seconds. We have the hello interval is 1 second. The master advertisement interval is 0.33 seconds. So the master down interval is 1.4 seconds, which is very close to the calculation we came up with, almost down to the millisecond. So what we're going to do now is we're going to go to R2. Let me bring these guys in just so you guys can see this all at the same time. For me, I like being able to see what's going on. I'm not like I don't like not being able to see what's happening. Go to R2, bring him up, and then we're gonna do the same ping. Do the same ping to this IP address, but see the problem is, notice he's still got the same ARP information. If we do a show ARP, oh, it changed over. It did flush. So okay. So he obviously can talk to that. We're going to do a telnet. I don't know, can I telnet to it? Is it still set up for it? Yes, it is. I'm going to do a Cisco, and we are in R1. So that's good. We're going to exit out of there, and we're going to do that ping again. And we're going to repeat it, but over here, what we're going to do is we're going to go to global config. We're going to type in interface serial 0/0, and we're going to get the shut command ready. See how long it takes to fail over. So we're going to hit the enter key. That's going. We're going to hit the enter key, shut it off, and it didn't actually drop. But wow, it's you know what? Let me jump up here and go to config T, interface fast season 0/0, VRRP1, timers, learn, show VRRP. Interesting. This guy's the bad. It didn't actually fail over. We show VRRP. We are tracking it, right? No, we're not. We're not tracking it. That's why it's important to verify your work. Interface fast season on 0/0. We're going to type in VRRP1, and track should be at the bottom. So track. All we have to do, it's not as simple as it was before. So what we're going to do, okay, so what we're going to do is we're going to exit out of here, and we're going to type in, that was track object, actually let's interface fast 0/0, VRRP1 track object 1 question mark decrement, and we're going to decrement 60. Track object does not exist. Okay. So what we're going to do is we have to configure IPSLA. So we're going to type in IPSLA. I wonder if this can work without IPSLA. Track object 1, and we're going to say interface, and we're going to track serial 0/0. Incomplete command, and then we're going to do line protocol. So now we're going to do question mark here as we can, okay, we can interface fast season is 0/0. We can say VRRP1 track, or track object 1, and we're going to decrement 60. So there we have it. So now we drop out of here, show VRRP. Now we are, there it goes. So track object 1 down decrement 60. So now we're gonna do is we're gonna do show run interface serial 0/0. Sorry, I'm used to Control A, Control W. Okay, we'll shut down. So config T interface serial 0/0. Type in no shut. Now it's gonna wait. Oh, this way it's not going to. I wonder if there's a config T interface as 0/0. VRRP1. We are going to preempt. There is a delay. Preempt delay is going to be minimum. We're going to give it 30 seconds. So before it fails back over, it's going to wait 30 seconds for it to come back up. So that's how we have that. So now we do show VRRP. Show VRRP. And we have, so here's what we have going on here before we start testing this option. We have the MAC address, the physical address, or the IP address, the physical address. This is the virtual MAC address. The advertisement interval is 0.33 seconds. The preemption enabled delay is the minimum of 30 seconds. And then we have priority is 150. We're tracking a state of fastest internet, or serial 000, serial 00, I'm sorry. Decrementing 60 out the priority, and the master router right now is .1, which is us. That's what local means. And we are gonna do. So now what we're gonna do is we're gonna go to interface serial 0/0. Type in shut, and then we're gonna come over here and hit the up arrow. Repeat this over here. Enter. And this guy didn't actually flip. Let's do a do show VRRP. Oh, now it flipped over. So it waited 30 seconds. It shouldn't have waited that, but it did. So what I'm going to do is the preemption, I'm going to enable the preemption is going to be VRP, or no shut. Interface fast used in 0/0. We're typing VRP1 preempt, excuse me, preempt, and we're going to say just enter. And so it should take this away. So this guy shouldn't wait. Do show VRRP, and preemption is able. He's not waiting. So okay, let's try this one more time. Interface serial 0/0. I won't be happy until it fails over right away. So we're gonna do shut, and we're gonna hit the up arrow, kick this guy off, and hit enter. It might be on this device that I have to do it, because he noticed it down, but I haven't seen anything happen over here. Let's do this. Instead of doing that, we're going to do 3333. We're going to ping 3.3.3.3. We're going to repeat it 200 times. And then I'm going to do this guy. I'm going to come up here and do interface fast used in 0/0. I'm going to type in VRR1 preempt. And that'll be that. So, because I want to see it fail over, and I haven't done that. So we're gonna type interface serial 0/0, and we're gonna type in shut, but we're not actually gonna hit enter yet. Come over here, hit enter, and okay, so that's what I was looking for. So turning off the preemption definitely did help. And so I wonder if I was to do a no shut. that would do anything. Okay, cool. So we're losing quite a few pings on that one because it should come back up though. Alright, so we're pinging again. Everything looks good, so I'm happy. At least we were able to see it actually fail over. That's the idea. We wanted to see it fail over. We got quite a few missed pings. We lost 19 total. In the beginning, we only missed, what was that, 8, which wasn't too bad. But then again, this is relying on an interface going down and having to be able to send pings back and forth. So it's using default timers to go back and forth. This guy's using default timers. So he's going to wait up to 3.7 seconds, 3.6 seconds, so before he actually flips over to this guy. So this guy right here is only going to wait 1.4 seconds to consider it down, and then he's going to flip over to this guy. So the timers are skewed, even though it says to learn, this guy wants to learn the timers from here. It's still going to be somewhat slow. So that's VRRP. I wanted to do an actual lab on it so you guys can see exactly how it worked. So that is how that works. Next one we're going to do is GLBP and how that works. I hope this has been informative for you. I'd like to thank you for viewing.